All right, welcome to another episode of Inside DFINITY. Today I'm sitting here with Enzo, who's one of our engineers, and we're going to talk a bit about both what he does for DFINITY, what he did before, but also talk about a recent event that he's held over in Europe. So maybe without further ado, Enzo, what is it that you do at DFINITY?
Thanks so much. So I work as a senior engineer here on DFINITY, working on the core client infrastructure. So I work on the main repository, that a bunch of packages that collectively make up the main DFINITY client.
Want to say a few words about what kind of technology we work with?
Oh gosh, I mean, there's so many. I guess I work on a little bit of just about everything, actually. I work on some stuff on networking. I work a little bit on the storage layer, more recently on the hypervisor. Work on some high-level architectural designs for the client infrastructure. A little bit of everything, actually, yeah.
A lot of complicated stuff. One thing that I've recently learned is what a hypervisor is, and if I hope I'm not going to screw this up, but it's basically a program that manages virtual machines. Right? Is that fair? Okay, cool. And so how did you join DFINITY? What did you do before, and how did you end up working here?
Yeah, so actually before I joined DFINITY, I was also working in the cryptocurrency space, working on a cryptocurrency exchange infrastructure. And actually it's there where I met Dominic. He and I were working on a project together, and he went off to start DFINITY, and was really excited by his vision for third generation blockchain-based computing network, and decided that was something I wanted to pursue with him.
Cool. Yeah, my next question was going to be, what is it that excites you about DFINITY? And you mentioned like third generation cloud computing infrastructure. How would you describe what DFINITY is in a few words? When
I say third generation, I mean that there's a lot of properties that we're looking for in a blockchain that we don't really see right now. And many of these properties, they somehow sort of trace back to these scalability problems that we hear so frequently about. And here at DFINITY, we have we try to address all of these scalability challenges in a variety of different contexts.
Cool. And what do you think are applications that will most profit from this newfound scalability? What are some maybe use cases of DFINITY technology that you are personally excited about?
These are applications that are, say, particularly latency sensitive, that right now may not make sense on a network like Ethereum, for example, which has a 15-minute transaction finality. But they may make a lot of sense on a network like DFINITY, which has transaction finality right now in just a couple of seconds, less than 5 seconds right now, and that's when the network's under load. So yeah, so you can just kind of let your mind wander about what those types of things are. And then of course, one of the things that I think is the coolest at the application layer is obviously access to this unbiased randomness at every single block height. And so, there's lots of cool applications that, require randomness. And right now there's no good way to get that in a way in which you feel that the randomness is truly unbiased and unmanipulable and unpredictable. So pretty excited about that.
Do you have any specific applications that you think are going to largely profit from this?
Yeah, I mean, I guess a lot of people are looking into, casino type applications. Also, I want to say like all casino type applications, but there's a lot of people who are having interest in DFINITY happened to be looking at it because it has those specific properties that make it a good platform to develop those kinds of applications.
One thing that I've wanted to ask earlier is, you mentioned that you joined or you were already working at a blockchain or crypto startup before, or company before. How did you first hear about crypto? How did you get into the space, and what was it that captured your attention back then?
So I was sort of working in a more traditional financial services space. When I graduated from school with my math degree, I ended up going into algorithmic trading, and then I got heavily involved in exchange infrastructure, and then kind of transitioned from there into financial market data and building pipelines around that. And I guess somewhere just being in the intersection of finance and distributed systems, kind of hard to ignore Bitcoin back in, I guess that would have been mid 2014 time, around then. And hard to ignore all the interest and enthusiasm and excitement around Bitcoin. And I spent more time looking into that, which is how I ended up at this company with Dominic, who I was working on Bitcoin exchange infrastructure with. From there, it's natural evolution. Obviously, when we were working there, we started looking at Ethereum, and then started looking into beyond the horizon, and that's what led here as to be working on DFINITY.
We are just about to open our Zurich office, but so far we haven't had any engineers in Europe, right? But we helped with a hackathon not too long ago. Actually, my home country, Switzerland. Unfortunately, I wasn't there at the time, but I think you flew over. Maybe you can summarize that event real quick. Like, what happened at that event? What kind of projects were happening, and maybe there's also something that you learned there.
So just responding to the first point, there are 2 engineers in Europe. Actually, we do have one in London and one in Munich. That's right, they're just working remotely. So I think they'll be really happy to know as soon as our Alpha gets up and running that they'll have a place to call home. But yeah, that said, Zurich is an amazing place where there's a lot of interest in and around Haskell, which is the primary language that we use to develop DFINITY. And to your point, I was over there in Zurich for Zurich Hack 2018, which is the largest Haskell hackathon. And there was 400 Haskellers there, so it was amazing for me because I had not actually seen so many Haskellers under the same room before.
Haskellers.
Yes, yeah, lots of fun. A lot of interesting projects going on there. Some in the blockchain space, some in many other spaces as well, though. But a lot of people there were kind of working on in some way, shape, or form, some blockchain-related project. I'd say maybe the 60 to 70% was blockchain, which is pretty unbelievable.
I know we do a lot of stuff in Haskell as well. Is there anything particular about the language or about functional languages in general that makes them kind of a better choice than others? So anything in the language that sets them up for blockchain kind of type of applications?
I don't know if the answer to that question is specific to blockchain, but I will say that there is a lot of nice guarantees that you get with using Haskell. GHC which is the Haskell's main compiler, does have some really cool features in it that allows you to sort of eliminate large classes of bugs that could exist in other languages that we just don't really arise in Haskell. So it's good from that perspective. But that said, I mean, you could do it in any language that you want, but so there's something about Haskell I find to be very elegant too, and when I write Haskell, it feels like I'm just writing math equations sometimes, and that comes very naturally to me.
Before we talk about the second event that you were in Europe for, maybe if there's someone else out there that resonated what you were just saying and they're looking to break into this space or even maybe get a job at DFINITY, what's the best way for them to get in touch with the space and work their way towards a successful career in blockchain or DFINITY?
I mean, the best way is just to get in contact with someone who's working on the core team. And first, I would say that you have to solidify what it is exactly that you're interested in, because any one of these blockchain projects, they really touch every single aspect of computer science, from cryptography to distributed systems to networking to virtualization to file systems and storage. I mean, you name it. I mean, there's some, depending on what your area of expertise is, chances are there's probably a way that you could apply that towards blockchain. So yes, I would say to anyone who's out there, don't feel like you're excluded, because we really do draw on every single part of computer science, as I said. And just figure out really what it is that you're most interested in, and see how there's a need for that in what we're working on. There's a lot of information online about that sort of describes the project in a sufficient amount of high-level detail that you should be able to see kind of where you may fit best in.
Good stuff. And then I think another way to learn more about the project, get in touch with us, is always to come to one of our meetups. And of course, beyond acquiring knowledge, you can also acquire one of these cool t-shirts if you're lucky. Which we both scored one. So you also ran a meetup when you were in Europe, right? Where was that, and what was the experience like?
Oh, it was great. Yeah, actually, 2 meetups. In fact, one was in London, and the other one was in Munich. It's just unbelievable, actually, just how much interest and enthusiasm you find across Europe for DFINITY. It seems like we're pretty far away, all the way based here in Silicon Valley, but it really is a global project, and it's good to see that we're having an impact on pretty much every continent, it seems like.
Cool. So maybe one last thought before we'll show some sequences from that meetup as well, because I think you really had some really good language explaining DFINITY, and you made some really cool points, so we want to include some footage there as well. But maybe one last question, is there anything you want to share with the audience, anything you want them to do or after they see this video?
Yeah, I mean, just make sure that all of you guys just keep in contact with us. DFINITY is due to launch, I think, in the next couple of months now, so yeah, it'd be a lot of opportunity for developers in particular who I know are interested in developing new kinds of products and services. I would say to you guys that we've worked really hard to create the simplest possible programming model for you guys. And I think you guys will be really excited once we have something out there.
And if you want to know when the time has come and the SDK is ready and the network goes live, then head over to dfinity.org and you'll find sign-up forms for our newsletter and various communities where you can exchange thoughts, ideas, and also get answers from some of our community members. All right, and with that, we'll cut over to Enzo's meetup. Thanks so much for spending a bit of time with us today, and we'll see you soon.
Schönen guten Abend. Good evening, everybody, and a very, very warm welcome to our very first Genesis Talks. We are very much thrilled to have Enzo here, straight from Palo Alto, who is deep diving us today in DFINITY, in the project he's working on.
Thanks so much. I cannot even articulate how excited I am to be here with you guys. I've been working on DFINITY for a little over a year and a half now, so it's really great to see so many people under one room who have the same kind of interest and enthusiasm for the project that I do. So DFINITY is building a general purpose computing resource that is shared over the internet. And so when I say general purpose, I mean that this computing resource will allow end users to run applications in the widest variety of application domains. And by shared over the internet, I mean that the computing resource itself is actually created by a network protocol running over the TCP/IP stack. So to start with, I mean, running any network protocol requires collaboration. It's true even for HTTP, for example. If the client and server aren't working together, you don't get very far. And it's no different with DFINITY. Collaboration is also required. And it's required to get consensus on the state of its virtual machine after the execution of code or storage of data. Or important characterization is that of DFINITY as a computing resource is that computation and storage is actually proportional to the number of participants in the number of host machines that are actually participating in the protocol. And as more host machines come in to participate, that means that we can do things like install more software on this computer, run more computation, and store more data. So as previously stated, we want to be able to run software in the widest variety of application domains. And to run general purpose software on a general purpose computing resource, you need an assembly language that is the build target of general purpose programming languages. I think most would agree with that. And we have a really nice solution here, and it's not specific to us, but some of you may have heard of it. But how many people, just by show of hands, have heard of WebAssembly? Okay, well, that's much less than I thought. So if you haven't heard about it, I would encourage you to go up and do some background reading. It's a new standard that's come to the web now, and in fact, it's an assembly language that's supported inside every major web browser, I think as of October of last year. So the idea, Chrome, Firefox, Safari, and so the idea is like if we're doing kind of computing on the web, how many of you are familiar with JavaScript at least? So. Okay, a lot more of you. Great. So this is some baseline here. So you may find that you want to be able to execute some code in the browser that is not actually written in JavaScript, and now you can do this, right? WebAssembly is a target assembly language of many different compilers. In fact, basically anything that has an LLVM backend can now generate WebAssembly, which is really cool. So it means that if you want to actually run some computation in the browser, you can actually write code in C and C++ now, and you can compile it down to WebAssembly, and then you can execute that WebAssembly inside your browser. And I guess the point here is that all major web browsers, they now understand how to execute this code, whereas yeah, it's getting everyone on the internet to agree about a new web standard is a really difficult thing to do. So the fact that we have WebAssembly now is actually a huge accomplishment. But it is also then it is also actually the assembly language that we use to run computations on DFINITY. Okay, and so what are some of those huge performance boosts that you get with DFINITY now, in sort of like when you look at third generation blockchains? I suppose what DFINITY is probably most well known for is bringing down transaction finality by an order of magnitude. So where transaction finality is defined as how long does it take in order to say with overwhelming probability that a transaction can no longer be reversed, right? So if I sign that Bitcoin script and I send it off to the network, I know that maybe some of you have heard, you need 6 confirmations in order to get to finality, right? So 6 confirmations, 10-minute block time. So an expectation, it can take 1 hour for that transaction to get finalized. Ethereum is a much faster block time, but the number of confirmations that you need is much higher, 37, and I think it works out to be 10 or 15 minutes, somewhere around that. Whereas on DFINITY, it's a few seconds, less than 5 seconds right now. Maybe not discussed enough is actually lowering cost of R&D. I mean, there's a lot of infrastructure. I mean, we spend a lot in terms of people's salaries, to paying people to actually maintain systems, and sort of with the idea of this internet computer and having the computer that can sort of run this software much more autonomously, there's a lot of cost savings there. There is this notion of a governance mechanism for DFINITY. We call it algorithmic governance, and so there is a way that's entirely decentralized of people who are participating in the protocol to actually decide how we want to kind of move forward, and not really allow that control to be passed on to any one specific person or people. Awesome. All right. Thank you, guys.